Okay, welcome back. We're going to be doing chemistry from chapter 7. And what we're going to do tonight is balancing equations. So, we're going to be given an equation in an unbalanced form. That's phosphorus, solid, plus oxygen as a gas, reacts to form P2O3, okay? And we're not going to get into what these are called, but that's an oxide. Potassium, some oxide of potassium. Of phosphorus. Yeah. Okay. Now, what I'm going to do here is I'm just going to arbitrarily start this one off as a 1, and then I'm going to see this other one has potassium, so that's, I'm going to say, I'm sorry, let me make this one a 1, and then this one a 2. So the idea is, I just picked an element that only shows up in one element on one side and one element on the other side, in one compound on each side. I could have started either with the oxygen or the phosphorus, but I decided I'll just start with the phosphorus, that's first. And then I want to make the same number on both sides, and I'm going to start with a 1 somewhere. First I put the 1 there, but then I would have had to put a half here. So I decided, okay, I'll put a 1 here, and that gives me a 2. So now the phosphoruses are balanced. Now the only thing I'm going to change is this. That's the only thing I'm allowed to change to balance it. The other ones I've already assigned. All I have left to balance is the oxygen. I have 3 here, and then I have 2 here. So I'm going to have to multiply this by 3 halves. Yeah. And that is a balanced equation, but we need to have small integer numbers. So we're going to multiply through by 2. That's going to give us 4, 3, and 2. So that's the final. 4 phosphorus plus 3 oxygen equals 2 phosphorus oxide. Okay? And now we'll do a double check. 4 phosphorus on each side, 6 phosphorus on each side, so it's balanced. Okay? Here we'll just get better at them as we do more. Okay, we'll start iron plus chlorine produces, that's chlorine gas, iron chloride. And I'm not going to bother to copy down what the states are. This is a solid, this is a gas. At room temperature, chlorine is a gas. And this is also solid. Okay, so this is similar to oxidation, only we're using chlorine, which reacts in a similar way that oxygen reacts. Okay, now, I'm just going to do like I did before. I'm just going to start with a 1, because I'm just going to start with whatever the first thing happens to come up. If this is a 1, then this has to be a 1. Okay? If this is if there's 3 chlorine, then this one has to be multiplied by 3 halves again. Now I'm going to multiply through by 2 to have 2, 3, and 2. Okay? 2, 3, and 2. And then we can just do a double check. 2 irons on each side, 6 chlorines on each side, so that's balanced. Okay? Now let's try the next one. Okay, chromium. Now for the purposes of balancing, we don't really need to know. We need very little about what's actually happening in this reaction. This is a chromium carbonate, and it's going to give us a chromium oxide and CO2. Okay? Now, in order to start off balancing this, I want to pick an element that only appears in one place on the 2 sides. Okay? That makes it easy. I could start here with the chromium, or I could start with the carbon, but I won't start with the oxygen. Let me just start with the chromium because it's the first one I come up against. I'll just put a 1. I'll just arbitrarily start with a 1. Now, if this chromium, there's 2 of them on the other side, there also has to be 2. So that's going to be a 1. Okay? Now, let's move on to another element. Like we only have one unknown now, is this one. And I can see here that if I simply look at another element, I could pick the carbon or I could pick the oxygen. But if I pick the carbon, for example, then there's 3 of them on this side because you don't get fooled. It says CO3, but then there's 3 of them, so there's 3. So this has to be 3. Okay? That's the only way this could possibly balance. Now we can do a double check by checking the amount of oxygen. There's 9 here, but now there's 3 here and 6 over here. If that didn't add up, for example, that means that this is an impossible reaction. It would be impossible to balance, so it could never happen. In this case, the oxygens did balance. And they have to balance if it's a real reaction, if it's a possible reaction. Okay, so let's go to number 4. Copper reacts with silver nitrate. Silver nitrate, that would be a solution. This is taking place in water. It's an aqueous solution. And that gives copper nitrate plus silver. This is a common reaction that takes place in high school chemistry class. The silver precipitates out. The copper is replacing the silver, but in this case, we're only interested in balancing it. We're not interested in why this is happening. That's a totally separate question. Okay, let's just start with the copper. Put on 1 for the copper and 1 for the copper. Okay? Now, let's pick something else. We could try this. We could try the silver because that's next. Whatever we put there, that silver has to balance what's there, but we're not going to know what that number is because it'll be the same. In other words, based on the information we have, we can't determine that. Let's move to the nitrogen. We see on this side that there are 2 nitrogens. Therefore, there must be 2 nitrogens here. So that's got to be a 2. Okay? And now we can see that the only unknown is the silver. So this also has to be a 2. So this has to balance now. And the only thing we haven't balanced is the oxygen. So we'll do a double check on the oxygen. 6 oxygens, 6 oxygens. It's balanced. And we're good to go. Okay, next one. Cobalt plus hydrochloric acid, HCl, gives cobalt chloride, which is dissolved, and a hydrogen gas. Okay, this is an acid plus a metal producing hydrogen, a hydrogen gas, and when this is dissolving, this is dissolving because this is aqueous, this is solid, aqueous, that's an acid. This is aqueous, that's a dissolved form, and this is the gas. This is an acid dissolving a gas, and you've probably seen that on TV or something. You pour acid on something like metal, it dissolves it and makes a hole in it. That's how you might rob a bank or something by pouring acid. Okay, but this is a balancing now. Remember, balancing. I'm just trying to make this more interesting because we might as well learn something about chemistry while we're at it. But we're really just balancing, so let's just start with cobalt. 1 and 1, cobalt. And let's move on to another element, and it's going to be the one that we're going to move on to is chlorine because we've already got a 1 in front of the chlorine, so there's 3 chlorines, so this has to be a 3. Then we'll move on to the H2. Now there's 3 hydrogens over here, and there's 2 over here, so to get 3, we're going to have to multiply this by 3/2. Okay? And then it's balanced. We've balanced all 3 things. Now we're going to multiply by 2 to even everything out. 2, 6, 2, and 3. Everything is balanced. 2 cobalts, 6 hydrogens, 6 chlorines. Okay, it's balanced. Okay, we haven't come up against anything that's been terribly difficult because this procedure is working every time. Okay, this is aluminum plus oxygen as a gas makes aluminum oxide. This is just the oxidation of aluminum. Okay, and that's a solid. This is what I call the storm window corrosion. Storm windows are made of aluminum, but they don't last forever. But they last pretty good because the oxide of aluminum does not flake off. It forms a shell on the outside. Iron, when it rusts, forms it flakes off. The surface then powders, and eventually the iron totally disintegrates. But aluminum oxide takes a lot longer to disintegrate. Okay, so I'm going to start with the aluminum. We're just going to put a 1 over here. Oh, and now we see we have a 2 on the other side. I could put a 1/2 here. But instead, I'm going to start with a 1 over here and make this a 2. Because that way, I keep the fractions out of it if possible. Okay, so there's 2 aluminum, so I'm going to make that a 1. That way I can make that a 2. Okay, now on this side, there are 3 oxygens. I need 3 oxygens, so I have to multiply this by 3/2. So there's no way around using a fraction for this one. But remember, now we're just going to multiply 3 by 2. That becomes 4, that becomes 3, that becomes 2. This is the balanced equation. You have 4 aluminums on each side. You've got 6 oxygens on each side. Balanced. Okay, the next one. Aluminum oxide, which is a solid, reacts with sulfuric acid, H2SO4, which is an acid that's aqueous, and this gives aluminum sulfate plus water. Okay, almost ran out of space there. Got a little bit crowded. I should have started over a little bit further. Okay, now I'll just start with the aluminum. Put in a 1 and put in a 1 because there's 2 on that side. Now let's start with something that also only shows up in 2 places. Now the sulfur is a good one because we see on this side there's 3 sulfurs. Because now I know the coefficient in front of this, so 3 sulfurs, so this has to be a 3. Okay? And now the only unknown is the water, and I can use either the hydrogens or the oxygens to balance that. The easiest one will be the hydrogens, because I see right here there are simply 6 hydrogens on this side, so there's going to have to be 6 hydrogens on this side, and that has to be 3H2O, and I didn't need any fractions. And now let's do a double check on the oxygen that's on each side. 3 oxygens here, 12 oxygens here for a total of 15 oxygens. And then here, 4 times 3, that's 12 oxygens plus another 3 oxygens is 15. So it's balanced. Okay. Next one. I'll start a little further over. Barium chloride. Okay, and that is that's a solution. That's an ionic compound. It dissolves in water according to the solubility rules. Plus sodium sulfate. And that's also dissolved, which is the so-called aqueous. That looks like a Q and a Q, but it's really an A. I didn't do that very good. Okay. And this turns into barium sulfate, which is a solid, plus salt, NaCl, this is table salt, which is dissolved in water, aqueous. Okay, ran a little bit out of space. I'll try to switch over to a different pen here. Makes it easier. Okay. This looks like a so-called double substitution. Both of these are dissolved, but there's going to be a precipitate. The barium, just so happens when the barium gets in close to the sulfate, it actually sticks to it. It won't dissolve in water like the sodium did, even though the barium did dissolve with the chlorine. And that just has to do with the type of bonding that's a little bit different on here and here. We're not going to get into that right now because we're just balancing. So I'm going to put down the 1. I'm going to put down the 1. Then I'm going to look for something else that I can balance here. And I could either use the chlorine or I could use the sulfur. Let's just use the chlorine. There's 2 chlorines. Now there's 2 chlorines on this side and there's no chlorine here. So that means this chlorine has to have a 2. Okay? Now it's down. There's only one thing that's unknown, and I can use the sodium. That's only showing up in one place, so this has to be a 1. Now, the sulfur and the oxygens have to be balanced. Let's just do a double check. Sulfur, 1 sulfur on this side, 1 sulfur on this side. Oxygen, 4 oxygens on this side, 4 oxygens on this side. So it's balanced. Okay? Now let's try potassium iodide, dissolved. Potassium iodide is a substitute for table salt. Instead of sodium chloride, potassium iodide is a salt, and I think it tastes salty, just like table salt does. Okay, lead, nitrate, NO3, 2. This is also aqueous, and this reacts to form lead iodide, which is a solid or precipitate. It's not soluble in water, plus potassium nitrate, which is soluble in water. Okay? I mean, this is written as potassium nitrate, but the reality is, in the solution, the potassium and the nitrogen are totally separate. And on the left side, the potassium and the iodine and the lead and the nitrate were all just floating around. Okay? But we're still calling this a reaction. Okay, let's balance it. Let's start over here with K. We'll just put a 1. Put the potassium, go to the potassium, and make a 1. Okay? Now we're looking for something else to balance. We can balance the iodide. The iodine. We got 1 iodine, so here we need 1 iodine. But this is I2, so we're going to have a half. Okay? Now we need something else to balance. So we can balance now. We got the lead. This is half a lead, so it's going to have to be a half a lead over here. And now we're going to multiply through by 2. So this is going to be 2. This will be 1. This will be 1, and that'll be 2. And now everything should be balanced. We can do a double check using the oxygen and the nitrogen because we haven't balanced them yet. And we see that there's 2 nitrogens, and here there's 2 nitrogens. 6 oxygens, and here there are 2 times 3 or 6 oxygens. So it's balanced. It has to balance. As long as it's a valid chemical reaction, it will necessarily balance. Because all valid reactions is a conservation of material. Okay, the next one we're going to do is iron as a solid plus oxygen as a gas forms iron oxide. This is just the rusting of oxygen. Okay, and this would be this is iron that's going to have the valence of 3 rather than 2. So that's ferric oxide. Okay, but we didn't need to know that. Okay, so we'll just start with a 1. Now here there was a 2. I could have started this with the 1, but in this case I'll just keep going and I'll start with a half. I'll put a half there because that's going to balance the iron. Okay. Now if we look at the number of oxygens that I have here, now you'll see I have 3 halves here. Now this I have O2. What do I have to multiply 2 by in order to get 3 halves? 2 times something is equal to 3 halves. Right? So what's that going to be? Well, X has to be 3/4. So you see, because I started off this way, I actually ended up having to do a slight amount of algebra or math. Okay? I didn't have to do that before. If I had started this with a 1 and that with a 2, it all works out a little bit easier. I just did this as an example to show you that you could still do this problem even if you didn't start off in the simplest possible way. Now I'm going to have to multiply through by 4 to get the balance. Let's see if that works out. 3 multiplies by 4 gives me 2. Now let's see if it's balanced. We'll check it. 4 iron, 4 iron. 6 oxygen, 6 oxygen. So it's balanced. We did it. And remember, you can't really ever go wrong on something like this because when you're done, you can always check it. If you got it wrong, you're going to know it. And you're going to go back and then you'll try it again. Okay? Okay, the next one is iron plus hydrochloric acid, aqueous, I'm sorry, I put a G. That should be a Q for aqueous. And when you put iron and hydrochloric acid, what happens is you get hydrogen gas. They have here FeCl2, but that's dissolved. But if all the water evaporated, then you would get a crystal of ferric chloride, or in this case, ferrous chloride. That's shown up here with a valence of +2, because the chlorine always had -1. Okay, and then we get the hydrogen gas. Okay, this is basically hydrochloric acid dissolving iron and creating hydrogen gas. So we're going to start with the iron, 1 and 1. Then we'll move to the chlorine. There's 2 chlorines, so they have to be 2 chlorines. Then we'll go to the hydrogens. There's 2 hydrogens, so they have to be 2 hydrogens, so that has to be a 1. So that should be balanced. And double check. 1 iron, 2 hydrogens, 2 chlorines. Balanced. Okay. Last one. Al2SO4. 3. This is some sort of aluminum sulfate. It's dissolved. And that's combined with a barium nitrate, also dissolved. That's going to produce aluminum nitrate, which is also dissolved. And it's going to produce this barium sulfate, which is a precipitate. Okay, I'm always running out of space, but okay, now we're going to balance. This one looks a little bit more complicated than the other one, but we're just going to do it the exact same way. But we'll start with the aluminum. If we start with a 1 here, we'll put a 2 there. So let's do that. That gets us off on a good foot. Okay? And then next, we can say, well, let's try balancing. We could either balance the sulfate, or we could balance the nitrate. Either one would work out fine. Let's just try the sulfate here. Okay, we got an SO4. Or actually, we're going to balance the sulfur. Okay, we could try balancing the sulfate, but I wouldn't recommend that. Let's just focus on an element when we're going to balance it. Sulfur. There's 3 sulfurs on this side, so there have to be 3 sulfurs on the other side. The only way to get 3 sulfurs on the other side is to have a 3 there. Okay, so we balanced the aluminum, we balanced the sulfur. Now we've got 3 bariums on that side, so we're going to need 3 bariums on this side. So now that should be totally balanced, and we can double check by checking the nitrogen. We have, remember now, this is a 2 here, so there's actually 2 times 3 are 6 nitrogens on this side, and on this other side is going to be 2 times 3 or 6 nitrogens, so that's balanced. We could also check the oxygen. This is 12 oxygens over here. 3 times 6 or 18. It's actually 18 plus 12, or there's actually 30 oxygen atoms on the left side. Now on the right side, it's going to be 2 times 9 plus 3 times 4. That's 18 plus 12. It's the exact same. It's 30. Okay? So it's balanced. And that is the end of the balancing exercises. Which chapter is that? Oh no, it isn't. On the back side there's 3 more. Okay? So we'll keep going. We're almost done now. Mercury, or mercuric oxide, because I think mercury is a +2 +1. But anyway, that's not the objective here. It's a solid. It's going to decompose to produce mercury, which is a liquid. It's actually a metal, but at room temperature, it's a liquid. It's one of the few metals that is at room temperature is a liquid metal. Okay, and you find mercury in thermometers. Everybody knows that. And also thermostats, so the old style thermostats. Okay, plus oxygen and gas. Okay, we're going to start with the mercury. Put in a 1. We're going to have a 1. Therefore, we have 1 oxygen, so this is going to have to be a 1/2. So it's going to balance out as a 2, 2, and a 1. And we don't really almost need to double check this one because this only had 2 elements in it. Two mercuries, 2 oxygens, balanced. Okay. Next one is sodium. Solid sodium reacting with water. Okay, this is a very colorful reaction because sodium metal, when it reacts with water, it lights on fire or practically explodes. But it burns in water. This is very unusual. If a firemen have to be trained. If they come to a fire and it's in a chem lab, you don't add, or even in a warehouse or someplace. If they happen to know that there's sodium present, that is the metal sodium. That's not normal. But if there was sodium metal stored someplace, you do not add water to it because it actually combusts or burns in water. So in this case, let's look at the reaction. Sodium hydroxide is what we have here, and that's aqueous plus H2, and that's a gas. And that, of course, is what's explosive, the hydrogen gas. The sodium there is very reactive. It's more reactive than the hydrogen. It's taking that hydrogen, it's taking the OH away from the hydrogen, and it is releasing hydrogen gas. Okay, we're going to balance it though. Remember, this is just about balancing. So we put a 1 here and a 1 here. Then what's left to balance? Well, the hydrogen. That's 1. No, not the one. We have 2 of them, so we're not going to do that. We're going to do the oxygens. So 1 oxygen and 1 oxygen. So this is going to be a 1. Okay. Now we go and do the hydrogen because we got 2 hydrogens, so we need 2 hydrogens, so it's going to be a 1. So everything's a 1 all the way through on this, and the method is still working. We didn't run into any dead ends. Okay, now the last one, calcium as a solid. Now in this case, we add calcium to water, liquid. This produces calcium hydroxide 2, which is a solution, plus a hydrogen gas. So this is a lot like the other one. Calcium, I guess, also might burn in water, or at the very least it produces hydrogen. It might not burn because it might not release as much energy as the sodium. The sodium releases hydrogen gas and enough energy to ignite the sodium gas. Okay, this one I'm not sure. Okay, but still, we're going to balance it by putting a 1 in front of the calcium. It's going to be the exact same approach. We're then going to balance off, let's say, the oxygen. This side has got 2 oxygens, so we need 2 oxygens on the other side. Then we're going to balance off the hydrogens. We've got 4 hydrogens on this side, 2 here, plus we'll need 1 more. So I'm going to claim that this is totally balanced. Let's double check it. There's 1 calcium on each side. There's 4 hydrogens here and 4 hydrogens there. So there's 4 hydrogens on both sides. There's 2 oxygens on both sides. So it's balanced. Of course, naturally, on a test or whatever, you don't need the 1s. You can just take those away. It's certainly not wrong, but it's not as nice. You don't need the 1, so take it away. Okay, and that is all of the balancing exercises. Okay, so now you see that we were able to balance all of these without too much trouble. Okay, thanks. See you next time.